Alright guys, so we are back, and this is the old Sabre 2000, and I got a mount for the GoPro on my head, so hopefully you guys don't get motion sickness. This is a big, you can't see it, but it's a Sabre 2000. It's got I think about a 3-foot by 8-foot table, so pretty good size machine. And we were doing a video last week, and the y-axis ball screw was making some noise, so we ripped it apart and cleaned it, put it back together. Still had some slop in the ball screw, so we said, well, let's measure what the ball diameter is, order some larger ball screws or balls and go from there. So these are 4.75 millimeter balls in the ball nut, and those measure out to 0.187, I think 1.870 something. So the next size up that we could find readily was a 3/16, so 1.875. So we're basically 5/10 per ball unit bigger, which should give us a 1 thou oversized reball on the ball nut itself. And we're going to rip this thing out and tear it apart and get it back in. We had about 3 or 4 thousandths of backlash in y-axis. We have a couple thou in X, but we've got I think a 10-foot ball screw that runs along the X-axis. So if this fixes the y-axis, we'll order another set of the same ball bearings for the X and probably redo the X as well. But that clanging noise, or that metallic noise when it switches directions, was concerning. I think it's because the balls don't have solid contact all the way around, so they would actually shuffle the balls from one side to the other and would kind of like lock up. So hopefully you guys again don't get motion sickness. We're going to jump in here in a second, pull the rear weight cover off, unbolt the ball nut, and then we'll go around the back and disconnect the servo motor and the thrust bearing casing and yank this thing out, and then we'll go sit down at one of the benches, take all the ball screw apart, and we'll go from there. So I'm going to grab one more thing here. I need to get a crescent wrench, and I'm going to try to monitor what I'm doing on my phone so I can actually make sure that everything stays in frame. Throw some gloves on here. Go walk through a messy shop, but keeping machines running is a priority around here. Let's see, do I have any small crescent wrenches handy? Still got all this stuff to put away and sort through from the last couple machines that we've parted out, torn apart, etc., etc. We just tore apart a big Akuma the other day. We got some tombstones, actually a couple of tombstones that we need to process down. Shipping area doesn't have one. Alright, let's go back over here. At some point I'll have a clean and organized shop, but got to keep machines running and got to keep making money, or at least that's the goal, right? There we go, crescent wrench. Alright, let's grab an impact and maybe a light and a phone, some Allen wrenches, and we'll climb inside here. And for the safety committee, this machine's off right now, so air's off, power's off, basically everything's shut down. The Z-axis has a brake on it, so there's really no way for the Z-axis to come down and smash me. and I've taken all the tools and everything out of the carousel, so there's really nothing other than me falling that's gonna do any damage. Alright, so we are now part of the machine. Since I have a headband with my camera, it's kind of hard to have a camera and a flashlight, so we're gonna have to kind of do this as multiple hands here. And the last time we were in here, I only put a couple of screws back in, or a couple of bolts back in the way covers, because I had a feeling we were going to be in here relatively soon anyways. So it should be just these 2 bolts here, one, and should be another one on the other side here. Let's see, and oh, there it is, it's over there. One of the next projects for this machine is going to be probably fixing up all these way covers, because they're supposed to have rubber scrapers that are basically crimped into these little stainless channels, and as you can see, there's no no scrapers left. Actually, there's a little bit left on this one, but every time this would come back and there'd be chips on the cover, and it would come up against the back cover, the chips would actually roll these over and smash them flat. So this way cover is in pretty bad shape. We have to probably every 2 weeks or so actually take this off and clean the chips out behind it, because it gets so bad, and which is really annoying. It's a good idea to do anyways on any machine, because not every way cover is 100%, so it is a good sort of maintenance practice to do. But these, I mean, there's sections on here that are completely missing, and you can see there's a huge gap. There's chips built up underneath all these, so it's not an ideal situation for a machine that runs pretty much non-stop. Let me get my hand behind this cover here, and I might actually have to grab a pry bar or something to actually get this thing to start, since these way covers, get some light in here, these way covers are, for this machine at least, pretty damn heavy. Let's see. And the table is all the way forward, so this front, there we go, this front cover, I wonder if I can, I bet I can't put this flashlight like around my neck or something. Okay, we can stand down here and push this back. There we go. Alright, so now you can see just how much chip grossness we have underneath here. And so behind each one of these, there we go, move the camera. Behind each one of these little circle covers is the bolts that hold the linear guides down, and what happens is those covers get pushed down with chips, and then every time a chip sits on top of it, the linear guides over here, there we go, basically just roll over the chips rather than slide them off or scrape them off. So at some point we're going to have to go through and replace all these with ones that aren't worn, or ones that are actually flat to the top of the guide to keep the chips from infiltrating it. But at that point, do we decide to pull the entire table off and actually clean out all of the runner blocks for the linear guides? So I don't know if that's what's making the noise that we're hearing, or if it's the actual ball nut or not, but we'll kind of have to try and see how that goes after we reball this and kind of see where we end up. So there's a grease line on the side here, so we've got to take that off. And I know that's an 8 mil, so I should have just grabbed an 8mm, but so be it. I should have grabbed a couple rags too, but that's what your work pants are for, right? You can see on this one just how much material sits in these little deals, so that will contaminate the roller units in the linear guides. So again, not an ideal setup for longevity by any means. So in this ball nut, it's a single stage, or I guess a non preloaded ball screw. Oh, I need an 8mm, so we're gonna have to jump out. We might as well grab a rag while we're jumping out again here. So it's a non preloaded ball screw, which means it's only one single stage. Let me climb out here. Climbing on top of somebody's parts that are going to get mailed out next week. Alright, there we go. I got a rag. And oh yeah, it's a nice nice dirty knee. It's getting a little warm in here. I'm running out of breath. Let's see. So we got a 7. We should have an 8 somewhere here. It's a 7 again. Five 16ths. Good enough. I'm running out of alright, and we're back. I'm running out of breath trying to talk, and even though it's September and the fans are on and the front door is open, it is still pretty warm in here, especially inside of a machine. Oh, I took a wrong step here. I need to get that foot further. There we go. Okay. Get my nice new DeWalt work shoes that are getting a bit of a workout here. And these shouldn't be all that tight. Because again, we were just in here. That one's snug. Okay. Let's try the one on this side. Dang. Well, I guess we're gonna have to climb back out and get a ratchet. Story of my life. Okay. Climb out this way. Try not to fall. Move my phone. There we go. Yeah. I believe I put the ratchet out back, kind of premonitioning, if that's even a word, being back here. There we go. Because that little 3/8 cobalt ratchet is fairly powerful, but it does not have a massive amount of breakaway torque. So there we go. I'm gonna situate myself here, put a rag down, there we go, so I can kneel, and we'll crank this thing loose. Yeah, that was not was not very tight. I mean, respectively, there we go. Okay. Let's see. These two. So the come on. Like I was talking about before, this is sort of a single stage ball screw, and most of our other machines, most of our Japanese machines, I guess I should say, since this is a European machine, these are made in England, these Cincinnati's, most of those, or sorry, most of the Japanese machines have a double ball nut, so they've got two ball nuts that have a shim in the middle, and you can adjust that shim, or you can grind a new shim to essentially take up any backlash that's existing in the system. So this one, since it doesn't have that, if it wears, it's just inherent in itself. There's no way to take that up other than to reball it or fix it. And if you can hear, yeah, it's probably hard to hear, but you can wiggle this ball nut around on the there you go, you can kind of hear it, but that's not a good sign, or not a good noise. You don't want this thing to make any noise at all. So that's probably what our noise is every time this thing moves back and forth. The other thing that it could be the actual motor. Oops. So that's the noise we were essentially hearing when we would switch directions. And the odd thing is, moving the ball nut is nice and quiet, but that noise is not good. So what we're going to do now, I'm going to climb around back and make sure I put my tools up here so I can get them. We're going to take the whole servo drive unit out with the bearings and everything all hooked together. Oh, I know what, I forgot to do this. No, it'll be okay. So that we can try to replicate this noise and see if maybe it's not the ball nut. Maybe it's something else. It could be something like the thrust bearings in the thrust housing, or I don't know. We'll see. We'll find out. We'll grab another rag here, and I'm gonna wipe my shoes off on my desk mat here so I'm not sliding all over the place. Back through the messy shop. I'm gonna grab, we'll grab a blue one. This is part of the joys of owning a business, right? You've got deadlines to make, customers to keep happy, people screaming at you, where's my parts, where's my parts, where's my parts, where's my parts? And you know, we've got, you know, 1 mil, 2 mils, 3 mils, 4 mils, 5 mils. All of these run. This old Kitamura is still getting fixed up here. We got to do tercite and some other things on that one. But it's Friday afternoon, about 4:30, when most people are going to be normally trying to go home. And you know, we're still here. I guess not where I'm still here, cranking away, trying to get machines back in action. So this machine, this big Sabre, essentially runs all of our adapter plates. And again, there's more junk everywhere. It runs all of our adapter plates, so it's basically running 24/7 on its own, just running that one product. So this machine is essentially in the eyes of sort of the available work time, I guess. You go grab a wrench to pull those cannon connectors off. This machine is basically saturated, which means, you know, we can only run whatever we want to run in it, or, you know, one job at a time, essentially. And because we are running, let's see, what do we need? I don't know where all my Nipex pliers are. There they are. Because we can only run one job in one machine at one time, this machine doesn't really get used for anything else, unless it's like an emergency job that needs more table space than the other machines that we have access to. So, okay, and we're back. Alright, so these are the two. Let's see if I can make sure I'm focused on here. There we go. Perfect. These are the two cannon connectors for the servo motor. One of these, this upper one, is for the encoders and the feedback and the overheat sensor. So you've got a bunch of pins in there. And the other one, this bottom one, is for the three-phase signal and the ground for the motor itself. So, and then I have some video from the last time I was in here. Let me try to turn this camera a little bit here if I can without setting it off. There we go. I have some video last time of the coupler and everything on the inside of here, back up in here. So I'll try to cut that in, and basically let me see if I can turn the camera here. There's a cable chain guide here. It's kind of hard to see with this big coolant guy in the way. So there's a cable chain guide here that bolts to the top of the bearing cover, and again, I'll try to take some extra video of that at some point and clip that in. So it looks like a 4mm. No, it's a 5mm. So we're going to take our regular old hand drivers here and come in and just crack these loose. And then the Y-axis cable guide bracketry is actually part of this same cover bracket, and that's how a lot of these Cincinnatis are. So you can't really remove the whole thing completely. It always just kind of stays in the way because the drag chain will actually hook to it. And I mean, you can unhook the drag chain and all that, but if we're just pulling a ball screw, I'm not that worried about it. So 4 6mm Allens on the top here. This one is going to be a little tough. Alright, so we got that guy loose. And I put our bolts. I dropped the other two down here next to the servo motor, but or they're probably underneath it now, but the servo motor is going to come off anyway, so let's put them down here in this coolant tray. I would much rather be loading and unloading parts, or packing orders, or working on R&D for new products, or something else to make money. But instead, we are here ripping apart a machine on a Friday afternoon to try to keep everything going. And maybe I need to get a chest camera holder, so we keep getting video of just the these are the air filter units for the Heidenheim scales, which on this machine, before we bought it, someone had already disabled, so these actually don't do anything and they're just turned off. So okay, let's see, I kind of have to lift up, there we go, and unscrew this. I'm sure the view right now is amazing for you guys for all 6 of you who are watching this. Alright, so this is the Y-axis cable chain guide. Let's see if I can get a good view here. So this plate right here, let's get some better lighting. Maybe. Alright, so this plate covers up the bearing housing, and then this channel basically supports and guides the Y-axis cable chain. So that just kind of gets pushed up and out of the way. There are 4 bolts that hold down the bearing housing, or the thrust bearing housing, to the main machine casting. And if I remember correctly, I only installed 2 of them because, again, I knew that I was going to be back in here again. So this is the main column for the machine here, and it's got all these pockets that are cut into it, and it's just hollow in here. There's nothing actually in here, and then the bottom of it, there's just a plate. So all this work that I'm trying to do from the bottom is kind of tough because it's just, there's a plate here, there's no actual access. So, and when we get this all the way out, I will try to kind of explain it a little bit further here. This one's almost hand doable here. If I can, again, try to get my camera and light. I need like a camera on my wrist. I think that would be probably, probably the most ideal, is if you had like a finger camera, if there is such a thing, to actually get in here, or some sort of a wide angle to be able to actually see a lot of this stuff. And again, every time we start touching this stuff, your hands get greasy, your gloves get greasy, and then it's hard to actually turn some of this stuff. There we go. Hey, almost. There's one. Oops, and my light's down. That's okay. There we go. There's one. It's just a regular old 10mm socket head cap screw. Nothing special. Throw that in the drip tray, and then there should be another one. Let's see if I can. There we go. Should be another one back on the other side, and again we'll get this thing apart here and slide the whole thing out, and you can see what we're working with. So we got number 2. Okay, so now these bearing blocks, try and put this up here somewhere so we can see. So the bearing block that actually holds the thrust bearings in place and mounts essentially the servo motor, the coupler, and all that is held in place by tapered pins, or it's, I guess, located in place. Sometimes they take a little bit of force to undo. There we go. And what they do is they will align this at the factory, and then they will go through and ream these pinholes. There we go. So this is an actual tapered pin, and it's got a thread on the top of it, so you can use a little puller to pull these out if you have to. And let's pull this whole thing out of here. Taper pins and all, ball screw, everything complete. Let me pop the other one out so we don't lose it here. We'll put this on a bench, if I can. Yeah, that one's stuck in there for now. We'll get this on a bench and do some tear down, but I need to find a bench first. Slide. Oh, it's a heavy combination here. Trying to get that there we go. Get it close to the body. Yeah, this is not a heavy, or not a heavy, not a light setup by any means. And I wonder why my back hurts all the time. Okay. Whew. All right. Set up our little workstation here. Turn the camera down a little bit. There we go. Plug the old phone in. And of course, everything falls down. We moved in here a year ago, almost exactly to the year, and we are still sorting through boxes and totes and all sorts of stuff, trying to get this place, one, running, and two, organized, all while trying to compete with competitors and keep bills paid, keep the lights on, keep things moving forward, etc., etc., etc. So we're going to run this ball screw all the way down to the end stop here, and that's to basically eliminate any noise that it would have made, because that other noise that it was doing while we were in the machine was a little concerning. And let me see if I have a piece of wood somewhere back here, just to kind of get the ball screw on a level. And not really. Here, we'll just use a can of cleaner. So, oh yeah. So that noise sounds like it's coming from the actual servo motor. So we'll check that out. So this is the bellow coupler that connects the servo shaft to the ball screw shaft, and this is not what this came with originally. I have another motor up front that'll show you what this came hooked to originally, or how this was coupled. So if you look at this coupler, get it off here. There we go. So this coupler is basically a sleeve with a slot in it, and that's where the set screw is. The set screw is on the side here, and it's got a 1/4 inch roll pin or dowel pin, and each side that is coupled has just a 90-degree notch in it. So essentially, oh yeah, this one's actually broken again. So this is supposed to go, it starts off as a round tube similar to this, and then you put it on the shaft, and then as you tighten the set screw, it smashes the roll pin into that groove and makes the connection. I don't really like this design for obvious reasons. This one's already starting to crack in a few places, so we'll probably replace this with a either a bellows type or a spider type, and it actually failed, caused a bunch of other issues in the machine. Some maintenance tech, I believe, actually left it loose because it would resonate when it was tightened all the way up, and that's usually a sort of a PID loop problem. This is just loosening the set screw on this. There's a PID loop issue, I believe. Yeah, that's a weird noise. So it would try to go to a stopping point, and then it would oscillate really quickly, and it would actually cause this machine to, essentially the entire machine would vibrate violently. So I believe they just left it loose, figuring, well, we'd rather have a couple thou of backlash on the machine versus not being able to run it at all, because it was so violent that it was basically making the machine unusable. So I'm going to take the 19 millimeters off for the servo motor. Use a little bit of electronic persuasion here. Two, three. The other thing I got to worry about is when this thing comes loose, I want to make sure my balance doesn't change and this thing doesn't go tipping and flying off into the wind. So that coupler is still hooked up, so it shouldn't really go too far. It's just the bellow is going to bend a little bit. There we go. Normally I have to put a wedge or a screwdriver or something in the brake, in the bellow, to kind of get it to release the actual shaft, because it is kind of a press fit. I usually have a mallet or two around here somewhere. Oh, there we go, a little dead blow action. So I'm going to kind of put my leg under the servo motor here and give this a little tap. There we go. And this should just kind of slide off. Screwdriver, and there is our servo motor. I'm gonna, trash can's not strong enough. I'm gonna put this on our chair. Again, I've got a whole bunch of work tables, but they are full of other projects. So we've got a little notchiness in the bearings here, but I can't actually feel any slop. Normally if there was slop in the bearings, you could hang this off the table like so, and then you could feel, you can kind of hear the noise or the notchiness in the bearings. So at some point we'll probably have to do bearings on this, but I'm not really worried about the notchiness. It's just going to make a little extra noise. So we'll take this, stand it up. Now our ball screw, since it's pretty good, will actually spin down this whole thing if I let it. So I'm going to kind of smack it up against the top stop, and it will stay up there. There's no point in having it free roll all the way down just to have to pull it all the way back up. So now our big problem is this guy. I feel like AVE with a messy workbench. So now that noise is probably what I'm hearing every time this thing runs back and forth. So we are going to do some disassembly. Let's get the other side of this coupler off first. If I grab the right wrench here. Same thing, this probably needs a little bit of wedging persuasion here. Okay. So these bellows style couplers are pretty cool. This is actually a Cincinnati part number. It came with a bunch of Cincinnati stuff I bought at an auction. It's a 3/4 bore by 3/4 bore, or 19 millimeters, which works perfect on these shafts for this particular unit. But as you can see, there's a quarter of this shaft that's been milled out, so it's got a big V groove in it. So this is not the coupler that this is supposed to go with, and these, if you give them enough torque, since there's no key or pinning, will actually slip. So if you're running hard and fast and rough, you can actually overrun them, essentially, I guess would be the word to use. And on the back of this guy, oh, that was not a good noise. On the back of this, there is an encoder that tells it where its position is. So, and sometimes these have to stay in a particular location. So what we're going to do is we're going to take the other side apart first, and if this inside encoder piece, so the piece that's stationary in here, it might slide all the way out as one unit, and if it does, great. If not, the last time we took one of these apart, all we had to do was realign the machine and it fixed the issue. But when I set this thing down on its nose, it made a popping noise. So I don't know if we got some play in some bearings or what the deal is. Oh, something's sliding around in there. I don't know if you guys heard that. So let's pull this top cover off. I hate when these pop and they switch the the switch on your ratchet. Even though this is this snap-on ratchet's probably about 20 years old by now. I think this is something I bought right out of high school back in the early 2000s. Not to date myself or anything, but so we can pull this top plate off, and usually this stuff is all symmetrical, so you can pull off. Oh, we got some lock washers in here, so we'll take a small screwdriver, pull our lock washers out here. Come on, there we go, and we'll kind of just, headphone users beware. I say hopefully we got a little bit of a gap. There should be an O-ring in here too, so we might be fighting that O-ring. Or we could be actually pulling the whole stator assembly out. Let's see. Oh yeah, it is pulling. So we are actually pulling the whole assembly out, because as I tap on the back of that, it actually is moving. So let's pull. I need something to set this on so it'll stay vertical here. Let's see what we got. Usually I'll use a tin can or something just to stand it up on, but we do have over in our scrap area, we should have there we go, a nice big hollow piece of something that I picked up probably at Industrial Metal Supply, I don't know, 10 years ago or more. Haven't found a use for it other than sort of bench top shop supplies. So stand this up, get it out of the way, put that there, stand this up, plop it on there, there we go. And this outer ring of the encoder, I don't know if this screwdriver is going to be too big. Nope, just a little bit. So we'll go grab a slightly smaller screwdriver. Hopefully you guys aren't bored to death of staring at my gross shop by now. There we go. And normally what I'll do on these, since we're not changing the phase orientation of the centerpiece, as long as the outside piece theoretically doesn't change, I'm going to put a little tiny scratch mark right where that set screw is supposed to go, just in case. And then these are kind of like a half moon deal, so you can just turn them and this will essentially just come right off. So yeah, it looks like that bearing is actually coming out together. So the whole bearing assembly and all that is coming apart. Now, we could take this back cover off. The problem with that is the wiring for the encoder is there, which would come off, but the wiring for the temperature sensor, which is these two yellows here, there's a open close temperature switch, so that would have to get unsoldered. And then these four for the motor itself are crimped, so we'd have to actually take this connector apart to get the whole thing to actually remove. So if we can pull the whole rotor, armature, whatever you want to call it, out of the body while leaving this rear cover on, that's what we're going to do. So I'm going to take this and lay it back down. I'm going to lay it down on top of our fixture here and just kind of tap on the back of this, and I can feel it and hear it moving. So now this is actually out of the casing. We might be able to give it a little pry power. There we go. We're actually moving. Oh, there we go. Next step down. Ooh, some crunchy noises in here. Oh, that's a interesting one. And we are almost out in the back. Ooh. So I wonder if the way that this servo, this should be I believe this is a permanent magnet type, so there might be something actually stuck to the magnets in here that is causing the issue. It's also going to make pulling this thing out a little more difficult. Oh, it looks like the magnet's actually coming with it, if I'm not mistaken here, because there should be, the magnet should be staked inside the case. Oh no, it's got an actual outside armature, so maybe the stator itself, I don't know. I've actually for transparency never taken one of these Vickers Gold Line servos apart. I've taken a lot of the let's go grab our pry bar. I've taken a lot of the Fanuc red tops apart, or red backs, I guess. That's like what we have on the big Lancer and our Kitamura, and there's actually one right here. Hopefully I can get a picture of it. So that's a 3-phase AC Fanuc style that kind of most people are probably used to, compared to like the yellow top Fanuc DC servos, the brushed DC servos, which are from days of old. Actually, you know what? Since I might have to reef on this, I'm going to put it back down on a flat surface just so I can be a little more graceful here. Oh. I'm still curious what that noise was that was clinking back and forth in this thing. Hopefully we find some sort of an answer. Oh, I'm prying up against the ring that's supposed to try to come out. Find a good spot here. Okay, we got kind of a good spot. Something is not happy. So I don't know what this big ring is. I can't just pull. Well, we'll keep working at it. Worst case, if we grenade the thing, I do have a couple of spares of these that we could replace if we absolutely had to. Now the hard part is, oh, come on, should be, oops, smacking the camera. It's moving, but not much. Let's try, let's put something underneath this side just to keep the weight. So it's moving around. Oh, it just went the other way. Oh, I think I'm probably fighting against the magnetism here. So let's see if I can. Oh man. It kind of feels like I'm fighting a magnet, but kind of not. Let's see, let's get that hinge in a good spot, and oh, we got the edge of something here that I think we can possibly, there we go. Oh yeah, there's some, oh, that might be just like an inertia ring or some sort of a resonance ring. Oh yeah, there's all sorts of crunchy stuff, it looks like, in here. I don't know why it's fighting me, other than, oh, and there it goes right back in. Let's see if we can catch that again. Come on, there we go. Because there shouldn't be anything in here that's really supposed to be fighting me. Oh, come on. Wow, this thing is, there we go. Come on. Come on with it. Oh, it just wanted to, just tried to suck back in. Man. Oh yeah, this is definitely a strong permanent magnet on that rotor. Jeez. So I wonder if something grenaded inside this, and then all the magnetic particles just decided to sort of make themselves at home and get stuck to everything. There we go. Oh yeah, that's a it's a nice strong magnet. So we're gonna put this, let's see, it doesn't look like we messed with the tacho generator or anything. No, it looks like it's all good there. Okay. Jeez, what a pain. Alright, now let's see if we can see some damage here. I'm gonna, oh yeah, that's great. That is amazing. Wow. So, holy crap, that is not good at all. So it looks like, if you look on this, there is actually grinding marks. Let me put this over here so I can make sure you're in frame. There are grinding marks on the back of this, I guess armature, rotor, whatever you want to call it, from the actual windings rubbing on, or I guess it was essentially rubbing on the windings. Let me grab my flashlight. Man, that is not the news that I wanted to see, but that would explain a lot of why this thing is pissed off all the time. So you can see here it's actually worn through, here it's worn through, and here it's worn through. So if you went to try to measure this thing, it would not pass. I mean, you would have massive amounts of electrical leakage in this. And the hard part about this is we would have to figure out why that was running into that, because this all looks like one piece. So I'm going to put this up here like this for a second. So this all looks like one solid piece. So between the magnetic core and this collar, which I guess would be sort of an inertia ring or something. I mean, those bearings sound yeah, these bearings sound amazing. They sound great. No noise. But I think every time it switched directions, it was actually essentially shorting itself out. So we would have to figure out why this was actually rubbing. So figuring out a distance from here to the beginning of the windings, I don't know if at some point this motor was rebuilt and this was actually pressed on in the wrong location, or what the hell is actually happening. So what we might do is might press this bearing out of this front housing and see if there's something inside this that allows it to move. But yeah, that's not good at all. That explains quite a bit on why, oh, there's my belly, why this was acting up the way that it was, but that doesn't really explain why it was doing that. The only other thing I can think of, sometimes these windings are staked or bolted from the outside. If this was dropped at some point and it was the whole winding actually shifted in the casing, or if this got so hot at some point that the case expanded and then the windings just freely sort of moved. I'm going to smack it a couple times and just see if it decides to move a little bit. Feels pretty solid. And again, this, yeah, I don't think this is going to move anywhere unless we actually heat up the casing and try to figure out what the deal is there. So, and we can see there's some melted plastic goodness from something. So can't really see anything on this side. I'm amazed that the servo amplifier was actually still running this without just constantly shorting out or throwing up alarm codes. But that would make sense why the current sensors were probably freaking out. We had to turn there's a stability sensing setting on the servo drive, and we constantly had to essentially adjust it to make this thing happy. And I mean, this would kind of be the reason why right here. We do have, oh, we're at 1%, so I might have to stop this video. I do have 3 other ones of these that have a different coupling fitting on the front, so we would have to kind of see if those were going to be compatible. But I'm going to charge up everything and we'll be back. Alright, so we switched over to handheld mode here. We're going to have to charge the camera. It's surprisingly, it only records like an hour of the video. But, so we pressed the end bearing housing off, and I guess this is some sort of an inertia ring. I don't know why it would really need to be on there. There's already enough inertia in the table and everything else, but maybe it's for some sort of stability or noise abatement, or I don't know what. But if we take this guy and this thing actually got magnetically stuck to the press, which was a fun thing to try to remove. Let's put it on here. Let's see if it'll actually fit in here, since I know this is not magnetic, and it'll stand up. There we go. So you can see sort of a line where this thing was and where it would have essentially stopped for when this sat on there. And there's rust on this surface here, which means it was never really pressed up against, oh, getting magnetic. But if we push this on or set this on, it just floats, like, and it goes way past the line where it's supposed to be. So this should have been maybe a pressed on piece that somehow was machined, or maybe at some point the machine got jogged hard enough where this thing spun and knocked itself loose. So we're going to yank the other servo motor apart that I have because it's got a different coupler design on it, and see if the windings and everything inside are the same. Make sure the encoder is the same, and we'll probably plug it in, turn the machine on, make sure it jogs and is happy, and yeah, we'll switch everything over. And this guy will probably I'll probably take this apart, drill it for maybe a couple of set screws, or even at least machine a spacer to go on the backside of it so it can't physically come down far enough to rub the back of these coils anymore on at least the new setup. And yeah, go from there. I mean, that's kind of a crappy find, but it is what it is, I guess. I'd rather have it something be repairable than not. And as far as the ball screw goes, we might just leave it the way it is and check the backlash on it, see how it goes. If it's only got maybe a thou of backlash, we'll leave it, because I don't know if the oversized ball bearings that we got, they might actually be too big. We might need like 2/10 over, not 5/10 over. But we'll come to that conclusion at some point. And alright guys, so we got both of the servo motors apart. So this is the good one. It's kind of a mess in here, as always, since now we have two servo motors taken apart rather than just one. I will pull both of them up here real quick. Alright, so these are both of the servo motors. They're the same body, same extrusion, blah 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 blah. So the big thing I was wondering about was, are these encoders the same? And based on all of the information on here, we've got the same voltage for the rotor and the stator, the same exact part number, same frequency. Serial numbers are only about 300 units off, so I would assume. The funny thing is one of them's Haro servo controls and one of them's Haro Inc., and they're made in two different states, so I'm wondering if they probably moved at some point or whatnot. We did take off the brushed encoder portion, and luckily on these Canon connectors, these pins, they basically, if it's focused, they basically just pull out of the rubber bushing, so there's no pin retention other than just friction. So easy enough there. And we did take the inertia ring and we did drill it and tap it for a set screw. And if you can remember, this slid on here and spun, so we're going to put some red Loctite on that and a set screw, and we'll probably mark on the shaft somewhere a dimple, and we'll dimple it, put the set screw in that dimple. The other thing we're going to do, this one you can see, let me grab my phone here so I can make sure I'm keeping you guys in the frame here. So this one is still locked to the shaft, and there's a gap, whereas the other one that we had did not have a gap. So I'm going to make a aluminum spacer to go in between this spot. That way, if this ever comes loose again on the new one with the set screw, that even if it's spun on the shaft, it will not be able to bash into those windings again. So we're going to make an aluminum spacer here, put this guy back on with a set screw, put the front plate back on, get everything pressed back together, and then what we'll do is we'll leave this not hooked up to the ball screw. And I keep getting messages here. We'll leave it unhooked mechanically, but we'll plug it in, turn the machine on, make sure it doesn't do anything funny, jog the machine around, make sure that the motor actually moves nice and smoothly, then we'll go ahead and put it all back together mechanically and cross our fingers. So we'll be back.